Now, the second question here now is what? We must determine what? The turning points. Determine the coordinates of the turning points, right? I must determine the coordinates of the turning. Determine the coordinates of the turning points there. Then also on this one, boys and girls, I'm going to give you 3 minutes to go through this one quickly, and then after that, we are going to discuss it. Right, thank you, boys and girls. I believe that you are done. I believe that we have the coordinates of the turning points as requested here. Let us look at this, at what you have. You can just share it with your friends next to you there to check if you did the same thing before I go through with you on this part here. Right, do you have the same answers? Now, if the answers are not the same, of course, don't worry. I'm going to explain everything. Now, make sure that you practice. The only thing that will make you to understand mathematics through practice. Practice and practice. Thank you very much. Right. Let us look at the coordinates of the turning points. Now, the question that you must ask yourself, especially when you determine the coordinates of the turning points, is how do I determine the coordinates of the turning points of the cubic functions? Remember now, it's different from what? It's different from the quadratic function. You still remember how to determine the turning points of quadratic functions? Yes. No, I can see that you still remember that one because it's just x is equals to minus b over 2a. That's great. But now, what about the turning points of the cubic function? What about the turning points of the cubic functions? Yes, you need to determine the derivative, right? Now, you can see here, f at x is equals to x to the exponent of 3 plus x squared minus 5x plus 3. Is that correct? Yes. And now from here, we determine what? F prime of x. Remember, that is the derivative. Remember, it's a gradient. It's very important. Derivative, gradient. Good. Now, what is the derivative of x to the exponent of 3? That is what? 3x squared. Good. That is 3x squared. Good. And now we go plus. What is the derivative of x squared here? That is 2x. Yes, that is 2x. You are 100% correct. And now we go to this one here. What is the derivative of minus 5x? The derivative of minus 5x is then what? It's a minus 5. Why minus 5? You know that you take 1 multiply minus 5. That will be minus 5. And now you say x here. From this exponent 1, you subtract 1. Now that will be 1 minus 1 is 0. And then x to the power of 0 is equals to what? Is equals to 1. 1 times minus 5. That is a minus 5. And then what is the derivative of a positive 3? That is 0, right? The derivative of a constant number, it's 0. Good. Now we have f prime of x. We have the quadratic now. When do we get the quadratic? When we have the derivative. It's very, very important. We have the quadratic if we have the derivative. You must remember this one, which is the gradient. Right. What do you know about the derivative at the turning point? Is equals to 0. Then we must let f prime of x to be what? To be 0. At the turning points, we know that the derivative is equals to 0. Now we have 0 here is equals to what? 3x squared plus 2x minus 5. Is that great? Good. And now from here you say 0 is equals to, we open the brackets, and now we say, okay, what are the factors of 3x squared? That will be 3x multiplied by what? Multiplied by x. Yes, that's where we must start. Right. We have minus 5 here. Boys and girls, once you have a minus 5, we know that we only have a negative when we take a negative multiplied by positive, or you take positive multiplied by negative. Don't say negative times negative, it's a positive. This one here will give you the negative, right? Then it means because this one here is a negative, then we're going to have plus and minus or plus. We're going to have minus plus or plus minus. Is that correct? Yes, good. But before we go to the signs, let us look at the factors of 5. What are the factors of 5? It's only 1 multiplied by what? It's only 1 multiplied by 5. That's good. Right. It means now, if I put 5 on this side, that will be 3 multiplied by 5. And then what is 3 multiplied by 5? 3 multiplied by 5 will give me what? A 15. Right? Immediately when I talk of the different signs, I know that I'm going to subtract. Now, then if I subtract 1 from 15, then of course, I'm not going to get what? I'm not going to get 2. Then that is why then I would say this one will be 1. 3 times 1 is a 3. And now, then 5. 5 minus 3, that is 2. Then of course, I will be getting the answer that I'm looking for. Good. Now, the problem now will be the sign. Now, this one here, because it will be positive, and this one here is going to be negative, because we are going to have 5x, and then we have the minus 3x. Now, 5x minus 3x will give me what? Will give me 2x. Boys and girls, so don't just write there and then to say, of course, I have these two brackets and then I filled in. We're not going to mark the work that we have written there. We just want to make sure that whatever that we have written down, it's very, very correct. And now, from that one, each and every time, you check if what you did is 100% correct. Good. Now you have the factors. From these factors now, what is it that you're going to do then? We can now say, therefore, there, x is equals to minus 5 divided by 3, or x is equals to a positive 1. Do you have these x values? Okay, great. Now, let us see now. Once you have the x values, what is it that you must do now? You must find the corresponding y values. Is that correct? Yes. How do we determine the corresponding y values? We take x, we substitute it where? In our original function there. Right. Now it means you are going to have what? F at what? F at minus 5 divided by 3 is equals to what? Minus 5 divided by 3 what? To the power of 3 plus minus 5 divided by 3 squared minus 5, and then we have minus 5 divided by 3, and then we have plus 3. Okay. And then of course, boys and girls, because I'm trying to save time, now I'm going to take this one to say, okay, that will be minus 5 divided by 3 here to the exponent of 3 plus, of course, we also have minus 5 divided by 3 squared, and then we have minus 5 times minus 5 divided by 3, of course, and then plus 3, no, plus 3, and then we have what? We have 256. We have 256 there, divided by 27. Right, when you write this one in decimal form, then we are going to have 9,5. Good. Now in coordinate form, because they said you must determine the coordinates, then x is what? X is a minus 5 divided by 3, and then y will be 256, divided by 27. Right. These are the first one. Right. The second one, of course, we take f, wherever we see x, we substitute it by 1. And now we are going to have what? Now we are going to have 1 to the exponent of 3 plus 1 squared minus 5 times 1, and then plus 3. That is 1 plus 1 is 2 plus 3 is 5. 5 minus 5 is 0. Then the coordinates there will be 1 is to 0. Look, now here I also have 0. Now immediately once I have 0, it also tells me that this 1 is also there, is also the x-intercept, right? And now, boys and girls, the other thing that you must learn is if a point is the x value at the turning point, is that correct? If it's a point, it's the x value at the turning point, and also the x-intercept, that point repeats itself. When you do the factorization, you'll most of the time find that that point repeats itself. It's the x minus 1 and x minus 1. Okay.